In this video, I'll explain problem number 22, part A, on page 63. So in this example, we're specifically looking at the full pods versus the constricted pods, and we're trying to figure out if these are the results we should get in an F2 generation for full pods and constricted pods when we recognize that full is dominant to constricted, and we've gotten this data. So first of all, add up the total number of pods you got. So you had 882 and 299, that's 1,181 offspring. Now the next thing you have to figure out is what our expected results should be. In the P generation, the original parent generation, they would be pure. That would be big C crossed with little c. That means the F1 generation should all be hybrids. When you cross two of these, a big C crossed with another big C, their offspring should end up having that distinct 3-to-1 ratio, or 3/4 full and 1/4 constricted. And that's what you're going to put down as your expected ratio. Then go ahead and plug in your observed. The 882 goes into observed for full pods, which is the dominant trait, 229 into the observed for expected traits. Observed for recessive. Then I want you to think about what we should actually expect. So in order to do that, you take your expected ratio times your total number of offspring. 3/4 times 1,181 gives me an expected of 885.75. You do the same thing with 1/4 times the total expected. A quarter of these should be recessive. That ends up being 295.25. Then you take observed minus expected. In this case, that ends up being a negative 375. And again, observed minus expected down here gives you a positive 3.75. Then you square this number, and that gives you your deviation squared. So here it's 14.0625, and you do that in both cases. Then you take your deviation and your deviation squared and divide it by your expected. So this 14.0625 divided by 885.75 gives me a chi-squared value of 0.016. We do the same thing here, deviation squared divided by its expected of 295.25, and that gives you a 0.048. You have to add both of these chi-square values together, and when you do that, you end up getting 0.064. Now, the next thing you need to do is figure out your degrees of freedom. We had two possible categories, full and constricted. So it's two phenotypes minus 1, because degrees of freedom are the number of phenotypes or categories minus 1. So 2 minus 1 is 1. You take that number 1, the degrees of freedom, you go over to your table. You find the degrees of freedom of 1 and go across, and you're going to look in here for the number that is closest to our chi-square value, because these are all chi-square values. So really, we don't see anything that the closest one is this 0.02, is the closest to 0.064. So we're doing pretty good, because we're going to say our probability is 0.9. So we're asking, can this deviation, this difference, be explained by chance? Anything in this dark blue area is going to fail to reject the null hypothesis, meaning everything's okay. This looks pretty good. In fact, it looks really good because it's all the way over here on the left. We're going to say yes, this deviation can be explained by chance.